Hello ladies and gentlemen, my name is Tallen Smith and I'm going to be doing a quick little tutorial here for you in a second, showing off how to do the graphing using the Singularity method in Excel or Google Sheets. So let's just get right into it. On the left side here we can see I have this practice problem. I'm going to do the math here and then I'm going to transfer it over into Google Sheets. This should all work in Excel though, so don't feel concerned if that's what you prefer to use. So here we have the problem that we used in our homework. I'm just going to go ahead and ignore the torque force on this side because it doesn't really apply for what we're doing right now. So what we need to do is we need to find these two reactive forces. And you can use any method you want to find these two forces. So I'm just going to go ahead and use moments. So we know that the sum of moments at A is equal to 0. So I'm just going to go ahead, and this is going to be A, this is going to be B. So we'll start from there, and we can see that with these forces, I don't know if you guys remember, but when we originally graphed those, what you would do is we would just assume that the entirety of the force was a single point in the center. So I'm going to do that. So for this one, it's going to be 10 Newton meters times, or Newton centimeters, times 50 centimeters, and that's going to be located right in the middle here at 75. So it will be 0 equals 50 times 75, because that's our distance, minus, and these are minuses, 5 times, oops, it's 500 here, my bad. Then it's 5 times 50, so 250, and that's located at 50 plus 50 plus 250 is 350, plus 25, so that's going to be at 375. And then finally we have our B force over here, so that's going to be plus R2, and it's located 550 centimeters. 550. Okay, so let me just go ahead and pull up a calculator. This is my favorite. So here, let's just do the math together. 500 times 75, that's still a negative. Minus 250 times 375. All of that is going to be divided by 550. And that gives us our value. It's a negative because these would be rotated, but I'm just simplifying. So R2 is equal to, positive. R2 is equal to positive 238.6, and that is in newtons. Oops. Okay, now we're going to do the same thing for point B. So the sum of the moments in point B is equal to 0. So 0 equals, and just like before, we're going backwards. So we have this first force, which is 250. And it's located 125 centimeters away. That's a negative. Minus 500. And this one is 150 plus 200, which is 400 plus another 25. 425 centimeters. And finally, we have our positive reactive force 1, which is 550 centimeters away. So let's go ahead and plug this in. 250 times 125 plus 500 times 425. And all of that is divided by 550, which gives me a number I didn't get for the homework. Hold on, I think I got one of these distance values wrong. 200, 450, 475, my bad. There we go. 475. That still gives us an answer that was different than before. Oh, jeez. 175. I thought this was 100. I'm looking at it from far away, my bad. There we go. So that gives us our reactive force 2, or reactive force 1, which is 511.36 newtons. Okay, now that we have all of our forces defined, we can go ahead and write it in Singularity. And the big question that people have is, how do we get the Singularity functions from this? And that is where I'm happy to say that it is very easy. So I'm just going to move all of this out of the way for a second. Okay, so to get our Singularity functions, what you want to do is you are just going to write down all of the forces. So at base, the original force is Q, and we're just going to start on this side and go this way. And we're going to list each of our forces and where they start. So our first force is this R1, and then we're going to do the Singularity. So for the Singularity, you're going to do X minus the distance that it starts at. So this one starts right on 0, so we're just going to do X minus 0. And it's the type of force that it is going to depend on the power that you put here. So single like forces are going to be to the -1. Loads, like we see here. So loads over an area, those are going to be 0. And finally, moments are going to be -2. So keep that in mind. And I'll just get this out of the way because I'm going to need that space. Up. So this is a normal force, so I'm just going to put -1. Then over here, we have minus our, I'm going to call this load 1. And it is X minus, it starts at 50. So X minus 50. Oops, and that's a close bracket. And that would be to the power of 0. Then, because these are loads over an area, you actually have to put when they stop by putting a positive with their final value. So we have L1 plus L1, X minus, and this ends at 100. And that's also to the power of 0, and we're going to do the same thing for those last two forces, so I'm just going to do that really quick. Minus load 2, where X is, and we have 50 plus 50 plus 250, which is 350, to the power of 0, plus when it stops, L2, X, and it goes another 50, so minus 400, 0. And our final reactive force, plus R2, and it starts where X is 550, and I just ran out of space, but that is a -1. Okay, so then from there, to get to our shear force and our moment, we have to take the integral. The integral of our Q gives us our shear force, and if we take the integral of that, we get our moment. So we're just going to integrate this, and it's very easy. So V is equal to R1 X minus 0, and then our -1 up here becomes a 0, minus L1 X minus 51 plus L1 X minus 100, also 1, to the second force, minus L2 X minus 350, 1, plus L2 X minus 400, 400, 1, and finally plus R2 X minus 550, and I ran out of room again, to the 0th. And it's important that we put these zeros just so you remember what they are, and you'll see why once I put these into Excel. So I'm going to go ahead and integrate this again, and that's going to give us our moment. So once we integrate this, it simply becomes R1 X minus 0 to the first. Now these ones, you have to note that when we integrate 1 to 2, we have to divide by 2. So make sure you don't forget to divide by 2 on these ones. So we have negative L1 divided by 2, x minus 50 squared plus L1, x minus 100 squared. Oops, squared, so I gotta divide by 2. It's very easy to forget those. Minus L2 divided by 2. X minus 350 squared plus L2 x minus 400. Forgot to do the time divided by 2 again. And finally, R2 x minus 550 1. Kind of fit it that time. Okay, so now the big question is, how do we take these 3 distinct functions, or 2, I guess, are the really important ones we're looking at. How do we take these 2 functions and how do we put them into Excel or Google Sheets? So I will go ahead and show you by switching over to my laptop, or my keyboard, in Google Sheets. So the first thing that I'm going to do is I'm going to define all of our variables into Excel. So I'm going to go ahead and say R1, R2, we need load 1, load 2. And you can put as many variables here as you want, but I tend to find that it makes it easier to remember, like, look at your code later on if you don't have that many variables. So R1, we have 511 newtons. R2, we have 238.6. For L1, we're just going to go ahead and put that base value that we have, so that's 10, and L2 is 5. So now let's go ahead and create our x, and to do this, you're going to decide on how many steps you want to take. There are a few ways of doing this, but I find the easiest way is just typing in. So I'm going to do every half step for my centimeters, and this is in centimeters, by the way. So in Google Sheets, and I'm pretty sure Excel, you can type in 2 numbers, and then if you just click and drag, it automatically fills in continuing that pattern. So maybe that was a little much. Yeah, maybe half steps was a little much considering how far I have to go down here to get to 550. But it means our graph will be very accurate. Never mind, Google doesn't want to go past 1,000. No, I'm going to go ahead and delete this. We're actually just going to do every centimeter. So 0, 1. Now if I go down to about 500, that should be enough. A little bit too many, so I'm just going to delete the ones we don't need. Up. Okay, and then I'm going to make sure to define all of the variables that I've made. So I'm going to select my entire X row, except for that one. And up here, you can name your variables, so I'm just going to name those X. Google, or Excel has the same thing, it just has a different name. And I'm going to name all of these to make it a little easier on myself. So we have R1, R2, L1, and L2. So now I'm going to go ahead and take these formulas and I'm going to write them into Excel. It's really easy. The only thing that you have to know is that the formulas up here, when you want to write them in Excel, here's how they should look. So you should have your force times x minus whatever distance it is with whatever exponent you have times x is greater than or equal to a. Okay? So we're going to go ahead and take this and we're going to write it in for all of our formulas. So we'll go ahead and start with V1. So we'll say V. So I'm going to go up here into the formula box, type in equal, and then I can type in R1 times, geez, fat fingers, R1 times x minus 0 to the power of 0 which just becomes 1, but I'm writing it just so you guys can see, times x is greater than or equal to 0 minus L1 x minus 50 to the power of 1. Oops. Turns red because in Google Sheets, at least, you need to make sure you put the multiply symbol. Times x is greater than or equal to 50. And we're just going to go through and do this for all of them. So plus L1 times x minus 50 to the power of 1 times x is greater than or equal to 50. Moving on to our load 2 minus load 2 times x is, or x minus 100 to the power of 1 times x is greater than or equal to 100 plus L2 times x minus oops, now I have some of my variables wrong. So L1 turns on at 50 and it turns off at 100, so these should both be 100. Then L2 turns on at 350 and it turns off at 400. Power of 1 times x is greater than or equal to 5. Oh, that is the turnoff. So 400. And our final force is plus R2 times x minus 550 to the power of 0 times x is greater than or equal to 550. Okay, once we hit enter on that, it'll suggest an autofill pop. If not, most of the time you can just double click on this little corner nugget and it'll fill them in automatically. And you can see we have our values. Are they exactly right? Did I do the math right? I'm not 100% sure. But we'll go ahead and finish this off and assume that it's right. So finally we need our moment. So let's go ahead and write our moment. When you're writing your moment, you can actually just kind of like cheat a little bit. So I'm just going to go ahead and copy this entire equation because it's mostly the same. Paste it in here, and then I just need to go and change a few minor things. So everything gets integrated. Our forces get divided by 2. Divide by 2. Squared. Divide by 2. Squared. Divide by 2. Squared. And change this 0 to a 1. And we will pop that in. And if once we take the graphs of these, we should see, hopefully, that they look okay. So insert, go to the top first, insert chart. And there we have our bending chart. Go. Make it a little, there we go. And when you're in Excel, you can hold Control to select additional non-adjacent squares. So I'm going to hold Control here, click there, scroll up. Insert, chart. And there you have it. I know that we have our 2 graphs there. And we have our answers. This is what it should look like, probably. I don't know. So I know it might seem a little bit tedious to write these equations, and it is, but because the math behind it is kind of so simple, it really speeds up the process. So there you go. That's how you do that for the next labs and whatever. Yay.